In this video, we'll review how the trigonometric function values of an angle relate to the geometry of the unit circle. By unit circle, I mean a circle that's radius is set equal to 1 and centered at the origin, so r is equal to 1. Here I've drawn the unit circle, centered at 0, 0. Because its radius is equal to 1, we can pretty easily find the exact coordinates of some of the nice points that line up with the x and y axis that live on the unit circle. So for instance, 1, 0, indicating that the radius really is 1, 0, 1. As I move into these other points here, the coordinates become negative, so minus 1, 0, and 0, minus 1 for the x and y coordinate. Recall that the equation of this circle should be x squared plus y squared equal to 1 squared, or 1, because the radius is 1. So this is the equation of the unit circle. I'm going to draw an angle theta in standard position. Recall that that means that the initial ray should lie along the positive x-axis. In this case, I'm sweeping a positive amount counterclockwise to get to my terminal ray, and when I do that, I hit a point on the unit circle here that has an x and a y coordinate. We can now form the standard trigonometric ratios, or the trigonometric function values of this angle theta: sine of theta, cosine of theta, and tangent of theta. Recall that we defined the sine to be the y over the radial value, the radius r, y over r, while on the unit circle, because r is equal to 1, is just y, or just the y coordinate on the point of the unit circle that the angle determines. So y there, that number, is the sine of the angle. That is what sine of theta does for you. It determines the y coordinate of a point on the unit circle. Similarly, cosine is x over r. Because r is equal to 1, we're just going to get x over 1, or x. It's the x coordinate of our point on the unit circle. That is the cosine of the angle. The tangent of the angle is y over x, and I'd like you to just spend a minute here thinking about what that represents geometrically. The y value here, in a sense, is representing the rise from the x-axis to our point, so it's this vertical length here, at least for this positive picture that I've drawn, where the y-coordinate is in fact positive. The x-coordinate is this run over to the point, so it's rise, y, over run, x, so it's rise over run, which you might more familiarly consider to be the slope of this line determined by the ray. So I want you to think of tangent as the slope of our ray. Imagine the line going through this ray, asking what its slope is, just like you would compute in an algebra course, as rise over run, and that is the y over the x coordinate. It is the tangent of the angle theta. Okay, let's look at some low-hanging fruit here, some easy examples to compute. I'm going to take theta to be the 0 angle. So I want the sine, the cosine, and the tangent of 0. So what do I have to do? I have to look at my angle. It starts along the positive x-axis. It has no rotation because it's 0 degrees, so it ends on the positive x-axis, and it hits the unit circle at the point 1, 0. By construction, sine of theta is the y-coordinate, and we just read that off from our point. It is 0. Cosine of theta is the x-coordinate. I just read that off. It's 1. And tangent, on the one hand, is y over x, so it's 0 over 1. And if I divide into 0, I get 0. That should make sense as the slope, and in fact, this line here, determined by the ray, is horizontal, and horizontal lines have a slope of 0. Let's look at another example. We'll take theta to be pi over 2. Recall that pi over 2 radians is 90 degrees, so I'm going to sweep all the way up here to where my terminal ray hits the top of the unit circle. I read off the sine, the cosine, and the tangent by looking at the coordinates that are easy to see on the unit circle there. The y-coordinate is 1. The x-coordinate is 0, and the tangent is the ratio 1 over 0. I put that in quotes because you know that you cannot divide by 0. That is an undefined expression. So it turns out that the tangent of 90 degrees of pi over 2 is undefined. It simply doesn't take a value for that angle. That should make sense. Geometrically, the line determined by this ray is vertical, and vertical lines don't have a defined slope. You have no run for an infinite amount of rise in some sense. So we don't really have a sensible expression that we can put here, but that corresponds with our geometric understanding of vertical lines having no slope. Let's look at pi over 3, that's 60 degrees. I'm going to draw a little picture here. Remember that we had this special triangle that allows me to get the sines and cosines and tangents, whatever I need, of 60 or 30 degrees from my equilateral triangle split in two. And we can read off the sine of pi over 3, it's root 3 over 2, the cosine of pi over 3 is 1/2, and the tangent of pi over 3 is root 3. Review the previous video if that's not clear. Now, what does that mean in terms of the circle? Well, if I draw the unit circle and I draw that 60-degree angle, that pi over 3 angle, it lands in the first quadrant, it hits a point on the unit circle, and apparently, because the sine is root 3 over 2, that's my y value that it determines. Because the cosine is 1/2, that's my x value. And because the tangent is root 3, that means this line has a slope of root 3 units. So if you go over 1 unit, you go up root 3 units on that ray. If I take the angle to be 2 pi over 3, that's 120 degrees, the geometry of this point, or this angle, will be closely related to this angle called pi over 3 here. And let's see why that is. Let's just draw the angle. What I have to do is go pi over 3, 60 degrees, and then another 60 degrees. That's going to put me roughly here. So 2 pi over 3 now lands in the second quadrant. The point on the unit circle that it determines is very similar and symmetric to the point over here in the first quadrant. What's changed is the x-coordinate now is the same magnitude but opposite direction. The y-coordinate is positive in the second quadrant. These values, root 3 over 2 and root 3 over 2, must be the same. So just take a minute here to absorb the geometry here. The x-coordinate has changed, but the y-coordinate has not changed in relation to this point over here in the first quadrant that we already discussed. Once we've agreed that that's the right point there, I can now get the sine of 2 pi over 3. It's the same as the sine of pi over 3 because the y-coordinate has not changed. It's root 3 over 2. However, the cosine, the x-coordinate, must be the opposite of the x-coordinate that we determined in the first quadrant. Over here it's positive x, over here it's negative x value on the x-axis. Therefore I have to change the sign of cosine of pi over 3. We knew that to be 1/2 from our special triangle, so I take the opposite value now to get the cosine of 2 pi over 3. The tangent of 2 pi over 3 should be the opposite of the tangent of pi over 3. There's actually a little error here in my calculation there. That should be pi over 3. And if I look at that, the reason for that is because if I look at the slope here, it's positive. This line is increasing. However, the line determined by this ray is now a decreasing line. As I move over, I go down that ray, and therefore the slope should be negative. On the other hand, I have to divide the y value, which is positive, over the x value, which is negative, and that ratio should be negative. So that's why I'm getting negative root 3. So what's happening here is that the geometry, the trigonometry of 2 pi over 3 is deeply related to this angle pi over 3 in the first quadrant. They have the same value but in magnitude, but possibly opposite signs depending on where your angle lines up. And the same thing would be true for angles that have similar symmetry, maybe this angle down here in the third quadrant or the corresponding angle down here in the fourth quadrant would have the similar kind of adjustments to be made. And in all these cases, we say that pi over 3 is the reference angle. That's the positive acute angle that has the same symmetry as the point that we're interested in. So pi over 3 is the reference angle for 2 pi over 3. Understanding that tells you what happens for 2 pi over 3.